So far, while we've been looking at costs and profit maximization in perfectly competitive markets, we've been focusing on firms' decisions in the short run when some inputs are fixed. And in that case, firms make short-run production decisions based on their marginal cost curve. In the long run, all inputs are variable. So in the long run, firms can decide, for example, how big they want their factory to be. And then their short-run adjustments in output will happen in the context of that long-run decision about the overall scale of the firm. So firms make those kinds of decisions based on a concept called economies of scale. The important factor when firms are making decisions about the overall size or scale of their production in the long run is the long-run average cost of production. So that's based on total cost, which we've seen before. So total cost is just the cost of all the inputs that you need to produce a certain quantity of output. And in this case, we're talking about total cost in the long run when all inputs can be varied. So then the long run average cost is just the per unit cost of production in the long run. So you take the total cost and you divide it by the quantity that you're producing. That gives you the long run average cost of production. So the general rule for deciding how large your business should be in the long run is to operate at the scale where long run average costs are lowest. That allows you to make the most profit on each unit that you sell because profit is equal to revenue minus costs, and operating where long run average costs are lower, it means that you're minimizing your costs. So here's a diagram of what long run average costs may look like for a typical business. So at the low end of production, when you're not producing very much output, firms tend to experience economies of scale. And that means that increasing production decreases average production costs. So typically that's because in order to start producing any output at all, firms need a certain amount of manufactured capital. So if you imagine a power plant, for example, power plants are very big, they're very expensive to produce. So if you built a whole power plant and then you used it to produce just enough electricity for one house, then the average cost of that electricity would be very, very high. But as you produce more and more electricity, you're spreading out those initial capital costs among more and more units of production. So that means that the average cost gets lower and lower. There may also be a range of constant returns to scale, and that's where you're producing enough output that your initial capital costs are a very tiny portion of your total costs. Your cost as you increase production just increases by the amount of additional variable inputs like capital and labor that you use, which means that each unit of production adds the same to total costs. So average costs remain constant. And then eventually businesses may reach a point of diseconomies of scale, and that happens if increasing production actually increases average production costs. And that might happen, for example, if the business gets so large that its managers can't effectively coordinate all the decisions that need to be made, production starts happening more inefficiently, and average costs actually start going up. So just to summarize, here's those three concepts again. Firms experience economies of scale when long-run average costs are falling as output increases, and that tends to happen towards the lower end of output when firms are operating at a relatively small scale. Firms experience constant returns to scale if long-run average costs stay the same as output increases, and firms experience diseconomies of scale if their long-run average costs start rising after some level of output. Now you can also see, going back to the same diagram, that there's a minimum efficient scale and a maximum efficient scale marked on the diagram. So minimum efficient scale happens when the long-run average cost curve bottoms out and stops declining. So after that point, firms are no longer experiencing economies of scale from continuing to produce. Firms should not operate below the minimum efficient scale, because if they do, they're not benefiting from all the economies of scale that they could experience. So they're not minimizing their costs. Essentially what they're doing is leaving some of their resources underutilized, like only producing a tiny bit of electricity from that whole power plant, or only putting a couple of patients in beds in a 500-bed hospital. The maximum efficient scale happens when diseconomies of scale set in and average costs start rising, and firms shouldn't operate above that level because it's inefficient to produce at a level that gives you higher costs. So a firm should operate somewhere between the minimum efficient scale and maximum efficient scale. And those 2 points of minimum and maximum efficient scale will vary from industry to industry. So for example, a company that does electrical work might actually operate efficiently at a fairly small scale because most of their inputs are things like tools and workers that don't involve huge capital or startup costs. But the minimum efficient scale for an airplane manufacturer, which has to build and equip a huge facility in order to produce any planes at all, would be much higher. So this model can give us some idea of how large we can expect individual firms to be in different types of industries in the real world.